Okay, so in this lecture, I'm going to say some stuff on Ajax. So first I'm going to explain the HTTP protocol, then I'm going to talk about Ajax, then I'm going to talk about WebSockets and JSON-P. So all of this is about how you can use JavaScript to talk to the server without reloading the page. So, and there's some, in coursework 2, there's about 10 marks for use of Ajax. And in coursework 3, you're going to have to use either Ajax or WebSockets because you won't be able to reload the page because you're only going to have a single page in coursework 3. It's going to be a single page web application, and you're going to have to use either Ajax or WebSockets or maybe JSON-P to communicate with the server and reload the data sort of dynamically. So this is pretty important for both coursework 2 and essential for coursework 3. Right, so start with the HTTP protocol, which you kind of need to understand for this all to make some kind of sense. So HTTP stands for the Hypertext Transfer Protocol, originally developed to exchange HTML documents as part of the development of the World Wide Web. But now it's, because it's such an amazing and great protocol, it's used to transfer data in other formats such as XML and JSON. Now, HTTP messages are usually transmitted over TCP, the Transmission Control Protocol, in combination with the Internet Protocol, but this is not essential. We could transmit HTTP messages using donkeys by sort of, shaving their fur selectively or whatever. We could use pigeons, transmit HTTP messages. It really doesn't matter. HTTP controls the format of the message. How we actually send that message is sort of separate from the definition of the HTTP format. And you get all this stuff on the OSI sort of network stack where each of the messages are wrapped in other messages. And so HTTP is typically wrapped in TCP, which is typically wrapped in an IP protocol, but there's different ways of doing it. So the usual way in which, how do I distinguish? No, okay. So we use HTTP for both websites and for web services. So with websites, we send a get, post, put, delete request to the server, and we get back a document written in HTML, CSS, and JavaScript. And this document is designed to be viewed in the browser. So your browser handles the sending of the HTTP message to the server, and it gets back something that's human viewable, right? And then web services, same idea. We send a get, post, put, delete request to the server, but in this case, we're getting back data written in JSON or XML format or some other format. And in this case, the data is designed to be read by a computer. So both websites and web services are using the same protocol, the same HTTP methods like get, post, put, delete. The difference is web services are sort of ways in which your browser or some other, your JavaScript running in the browser or some other program running somewhere can actually pull data from the server. And this data is in computer-friendly format, whereas websites are designed to be viewed by humans. So they have their different uses, and I'll just sort of give you a little demo to sort of make that clear. So here's the BBC football page, right? It's, looks pretty, right? It's probably got some scrolling stuff somewhere, lots of pictures, a little flashing button there, you might notice. So it's glossy, it's lots of CSS, designed to be read by humans, right? We look at that website and, we digest it using our eyes or whatever. And to get that website, the browser is sending a number of HTTP requests to the server and pulling back the CSS and the JavaScript and the HTML and so on and so forth. On the other hand, here we have what you get if you use HTTP in the browser to access a web service, right? So this is a web service describing like football competitions. So in this case, the data is all in JSON format. You've got all this stuff you're very familiar with, but obviously it's not very human friendly, right? I mean, we can read it, but not that easily. But this is pulled using exactly the same protocol, but it's for a different purpose. Maybe I'd have JavaScript running in the browser, and then that would pull this data and then use that to display, dynamic information about football competitions or something like that. So that's a web service, and the other one's a website. So a typical HTTP session, you've got the server sitting there, something like Apache, listening on a particular port, waiting for a message. Then we have the HTTP client. Typically, a browser operates as the HTTP client, but it could also be some Java, some Python, some other kind of program can also act as an HTTP client. It establishes a TCP connection to a port on the server, usually 80 or 8080. The server receives this message from the HTTP client on that port, through the socket or whatever, and it sends back a response, and then that's it. HTTP is a stateless protocol, which means that you have like one request, one response, and then that's it. There's no sort of persistent connection between the client and server. No sort of streams or anything like that. So here we have the example. So here we have a request. We send, this is what the header of the HTTP message looks like. So we have a get. This is the method that the client's sending. It's sending a get request. I'm going to come to more of that later. It wants that particular page, index.html, and this is the location, like the host, the sort of full URL in that case of the host. And then that's sent to the server processes that request and then sends back a response. It maybe, there's lots of sort of bits and bobs you don't have to worry about here. The crucial thing here, you've got a response code saying that message, it's all okay. And then you've got, so this is the header, this is the header of the message being sent and the header of the response. There's a bunch of bits and bobs that occasionally you might find useful. And then the server is also sending back the message from the server also includes a body. In this case, it's containing HTML, probably to be read by a human. But this body could also contain XML, it could contain JSON, and so on and so forth. Now, HTTP has a number of methods. And the four most important ones are get, post, put, and delete. And you can see in the header of the request where the methods being specified there. Now, one use of these methods is to manipulate resources. And there's a sort of specific way in which you can use HTTP to manipulate resources, which is called the representational state transfer, or RESTful. So if you're applying for jobs, you'll often see RESTful as one of the keywords that they use in the sort of list of, complicated technical keywords. And so I'm going to say a little bit about what that means here. And if you're feeling keen, in your third piece of coursework, you could use HTTP in a sort of systematic, RESTful way to manipulate resources on the server. So the idea that each resource has this, what's a uniform resource identifier. So there's a little bit of confusion between URIs, which are universal resource identifiers, and universal resource locators, or URLs. But, we can just sort of be a little easy about that. And we're using the HTTP methods in very specific ways. So get retrieves a resource, post creates a new resource, put changes the state of the current resource, a resource that already exists, and delete destroys a resource. Now, in some websites on this, you might find post and put reversed. So if you're doing the big presentation to the managerial board on the new use of RESTful in your company, you might want to flag this ambiguity or double check it. But I think this is the correct way of doing it, that post creates a new resource and put changes the state of the current resource. And as I said, these are stateless interactions. So as I said, there's a little bit of ambiguity here between URIs, which are just a sequence defined as a sequence of characters used to identify a resource, and URL, which is the sequence of characters used to identify the resource that includes both the location and the network protocol. So that you all know what URLs are, and URIs are sort of, it could be just the ID of the resource or something like that. So here's a little example. I think this is tutorials point tutorial example. And as I said, these are the wrong way around, I think, in this example. So here's a URI, which is just a sort of unique identifier or location of the URI of the resource on the server, right? It doesn't tell us anything about the protocol. It doesn't tell us anything about where that is, right? If we type that in from anywhere in the world, we're not going to find it. But relative to the server, this kind of works, right, the URI. So if we send a get to this URI, we can get a list of the users. If we send a list of get to the users /1, we can get the user with the ID 1. Let's suppose that's post. And we can do post users /2 would insert a user with ID 2. And put would kind of update user with ID 2, again using the same URI. And then delete, we specify the ID of the user we want to delete. We could delete all users if we didn't have that. And options, supported users. I've forgotten off the top of my head what idempotent is, but you can look it up. So there's other HTTP methods. Get, post, put, and delete are the main ones you use to manipulate the resources, but you may find it useful sometimes use head or trace or options, connect or patch, and so on and so forth. An important part of the HTTP protocol is this idea of a status code, and you're going to use that when you come to Ajax. So the first line of response contains a status code, and this might be, hopefully it's okay, which means everything's worked fine. There's kind of bad request, where there's some kind of problem in the request you've sent, or not found if you can't find the resource you're trying to get hold of, service unavailable, and so on. There's a huge list of these things, including one joke one, which I can't remember the code for. So just have a look online. So let me do a T, I think, the joke one. There's some discussion about taking it out. Anyway, so if you look in the response, this is where the status code is here. And so you need to check that when you're using Ajax, that the response, that you've made a successful request and received an appropriate response. So with the RESTful approach, you're typically using the URI or URL to specify which resource you're manipulating. So if I say get to blah, 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 /users, I'm getting all users. If I get user/1, I'm getting user1. That's the idea here. And that's all fine. And you can use Apache. You can configure Apache so that it'll map these onto appropriate scripts. You can do some clever stuff with Apache. But often it's actually not that convenient to do things that way. Sometimes it's actually easier using what's called a query string that's appended to the end of the URL to specify which resource we want to access or manipulate in some way. So here we've got get user service. Now this could be a particular PHP script here. And this could be the same PHP script, but then I can pass what's called a query string at the end of this, which can then be processed by this PHP script here. And then we can get different users, and they can all be accessed by the same script on the server, which is kind of easier way, more intuitive way of actually writing the code. So I'm going to say a little bit about what a query string is. So what a query string, the format of the query string is, at the end of the URL, you have a question mark. Then you have a series of key value pairs, and then these key value pairs are separated by an ampersand. So you can pass as many of these things as you like, but the key thing to remember are the query string starts with a question mark, only one question mark, series of key value pairs, key equals value, so size equals large, color equals red, and then you separate multiple key value pairs with the ampersand there. That's how the query string works. Safer to use lowercase, don't include spaces, or you have to do weird kind of URL encoding stuff. Just don't bother getting mixed up with spaces, just make your life harder. Avoid spaces, stick to lowercase, and then it should all work okay. If you have to use spaces, you have to probably URL encode them somewhere. Now on the server side, we can pass the queries, we can use this query string like that, and on the server side, our PHP scripts can access that query string and use that to control the response that's sent back to the user. So if the server receives this request, HTTP, blah, 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 name equals Albert, age equals 7, this is a GET request. So it can reply with a list of cats whose name is Albert and whose age is 7, right? Nice and easy. So, and if I had name is George and age is 13, it could reply with a list of cats whose name is George and whose age is 13. Let's suppose it's a big and comprehensive cat database. Now, we use query strings with GET. We don't use query string with POST and PUT. With GET requests, the data sent to the server is encoded as a query string in the URL, which is all nice and easy. And then we can bookmark or cache. We can bookmark the URL in a browser or whatever, and the browser will probably cache what's sent back by the server with a URL in response to a URL with a particular query string. So in this case, we can bookmark this complete URL, and every time we go to that bookmark, we're going to get a list of cats whose name is Albert and whose age is 7. And the browser will probably cache the response that the server sends back in response to that GET request. Data sent with POST and PUT works in a different way. If we want to send data with POST or PUT, we're kind of creating a new resource, we're changing this data resource, and we don't want to put that on the header, because then each time we bookmarked, we return to that page, for example. We don't want to put that in URL, sorry. Because each time we return to it, we'll be changing the resource. Whereas actually with GET, we're just viewing this data resource. But we don't want to bookmark something that changes or inserts a new resource. That'd be a bit of a disaster, right? So instead, the data sent with POST or PUT is included in the body of an HTTP message. And in this case, same idea. You've got a set of key value pairs separated with ampersand, but in this case, it's in the body. So here's a POST request. There's the header there. We're saying it's a POST message. And inside the message body, we've got user equals Abby and course equals Java. And this is inside the message body, so you don't actually see it anywhere. except it's all sort of wrapped up by the code that creates these messages. So these are the key differences between GET and POST. GET requests can be cached. The GET requests remain in the browser history. They can be bookmarked. They should never be used as sensitive data, and they have length restrictions and should only be used to retrieve data. We're pulling stuff from the server, and so we can bookmark it, cache it, and all the rest of it. With POST requests, they're not cached, so you sometimes, if you're filling in complicated web forms, you'll sometimes find this kind of confirm form resubmission sort of page where the browser gets a little nervous and shows you this kind of, I don't know quite what to do, but if you want to resubmit this data, you can resubmit this data. That's because it's a POST request, not a GET request. So POST requests don't remain in the browser history. You can't bookmark POST requests, and there's no restrictions on data length. Okay, so hopefully that's given you a little bit of an introduction to HTTP, GET, put, POST, and delete. So now we can go on to Ajax. So Ajax stands for Asynchronous JavaScript and XML. And the basic idea behind it is that the JavaScript can autonomously communicate with the server without reloading the page. Now, the reason it's called asynchronous JavaScript and XML, well, the asynchronous means you send the message, and then you've got a sort of event handler that handles the response to the message. So it's not like the JavaScript doesn't pause while it's waiting for the response. The JavaScript has a separate handler that's invoked when the response comes back. Obviously, it's JavaScript. The reason it's called XML, which is kind of frustrating, but never mind, is that back, 10 years ago, 15 years ago, whatever, XML was all the rage, right? HTML was even rejigged so that it was XML compatible. Everyone's documents were in XML. I even wrote some stuff on using XML to describe states of consciousness, right? XML was dead cool, right? But over the years, people kind of realized, well, XML is maybe not that cool after all, that it's kind of bulky. It's not that easy to parse. It's not remotely compatible with JavaScript. It's kind of a bit of a pain if you're doing web programming and using web services with XML. So you will still find some web services out there that use XML, but pretty much everyone has moved over to JSON now. JSON's really the way ahead with this kind of stuff. So these days, it should be really asynchronous JavaScript and JSON maybe, but it'd be one more character type, I suppose. And it'd be a JAJ, which would be a little bit less sort of comprehensible. Yeah, anyway, never mind. Rightio. So the idea, anyway, is that the JavaScript can send messages to the server on its own, receive some data, and use that data to change the contents of the page. So helps us build single-page web applications, such as you're going to do in Coursework 3. So if you look at Gmail, Google Maps, Facebook, Outlook, and so on and so forth, without looking at the code, I'm not certain, but almost certainly they're going to be using some version of Ajax in them. So what I'm going to show you in this lecture is the standard techniques for using Ajax. So jQuery and other libraries will wrap up these slightly verbose standard methods in a more compact syntax, and you might find it easier to use the jQuery Ajax, which you're welcome to do in your projects, no problem at all. But I'm going to show you the bog standard ones here, and then if you want to use the other ones, that's absolutely fine too. So we're going to have a very simple Ajax example. Now, something to bear in mind with all these examples is the browser is capable of sending the same requests as the JavaScript. So the first thing to test whenever you're testing out your Ajax is check that the server is giving you the correct response back, and then you can check that the JavaScript is pulling the correct response back from the server as well. So you can check the response from the server in the browser, then check the response, then check that the JavaScript is getting that response you're expecting. So in the simple Ajax example, I've got a file called demo1.php in the same directory as the HTML page. And all this PHP is doing is echoing hello from server. Now, if you need to revisit PHP, there's going to be a lot of it in the next couple of lectures. So I recommend if you've forgotten what PHP is, go back and rewatch one of the earlier lecture that introduces you to PHP. Because I'm not going to go over how PHP works again here. That's all covered in the earlier lecture. So we've got some PHP that's echoing back hello from server. And then we've got a simple Ajax example on the client. So I'm not sure how much you can see of this. I've included all the examples in the course website, but I think I'll go through it now just to show you. So here we have a bit of the HTML on the page. All the HTML pages, a paragraph here. The paragraph has a button, and when you click on button, oh yeah, so this is a div with an ID server content. So everything inside this div is going to be replaced by the JavaScript with the message from the server. So we've got a paragraph here and a button. When you click on the button, it calls load content. So that's what it looks like. Dynamically loaded content goes here. When you click on load, what comes back from the server will be stuck in this part of the page. Then with Ajax, you have to first you start by creating a request. So var request equals new XML HTTP request. Easy enough. Then what this is here is the handler that's invoked when the message comes back from the server. So this is the request on load event. When that event is triggered by the response from the server, it will call this anonymous function. And this anonymous function will check, firstly, it checks that it's, the message from the server is OK. Remember all that stuff about status codes? That's checking the HTML status code, HTTP status code, sorry. And then we can pull out the response from the server because we have request. This request will now have the data from the server as this response text property. So we've got the response data here. And now all this is doing is it's sticking this data here that's coming back from the server into this div. That's all it's doing. Or if we had an error from the server, then it's going to just generate an error message here with an alert. Final part, so we've set up the event handler to handle what comes back from the server. And now all we need to do is open a connection to the server or start the, set up the message. So we're sending a GET request to this, script here, which is in the same directory as the JavaScript running in the HTML page. So we open up the connection and then we send the message. Once the message has been sent, it will then, and we'll get a response and that'll trigger this part of the code here, assuming the server's up and all the rest of it. So I can give you a little demo of that. Okay, so if you look here, here's my PHP script. And it's echoing hello from server. That's all it's doing. Very, very simple PHP script. And then here's the JavaScript. So this is the HTML. When I click on load, it's going to send the Ajax message to the server. It's going to get back a response and replace this with what's coming from the server. It's going to replace this stuff with this, which is coming from the demo 1 PHP script. So if I click on load, there we go. It's replaced it's taken the content from the server and stuck it in the page. Now, that's a kind of basic example, right? But what we often want to do is we want to send some data to the server, process it on the server, and either change, put some stuff in the database or use that data to control what we send back to the user. So on the server side, we need to be able to access the query string, especially with GET requests, for sure we do. And so we do this using these predefined variables containing the query string. So sorry, the query string only applies to GET. With POST, anything that's sent to the server using POST, we can access using this predefined variable $_post. So PHP is a bunch of kind of global variables, and the GET global variable contains all the query strings that have been appended to the URL, and the post contains all the query string stuff that's been bunged in the message body and sent with post. So these are just an associative array with a set of keys and values. So if we want to check that a particular key value pair has been sent to the server, we can use this array key exists method to check that get or post contain the query parameter. So here's an example. So if we do, on the client side, we've got some JavaScript that opens a request sending a get method to demo2 PHP. And here's the query string here, name equals David, question mark, name equals David. Standard sort of URL with a query string appended. On the server side, I can check that the name variable, the name key exists in the get, in the PHP get variable. If it exists, if this returns true, then I can access it using the square brackets and specify the name of the variable here. Otherwise, it's going to say hello stranger. So this will work, except this isn't particularly safe because attackers, hackers, whatever, can put any kind of stuff here, and if you're not careful, that can end up manipulating your PHP, or you create all kinds of problems. So it's not recommended that you access get and post directly. Sometimes you'll find that you actually have to do this because I found it tricky to get like JSON formatted data out of get and post in that way. But with standard stuff, it's not recommended that you access get and post directly. Could have malicious data that could have database or server. NetBeans does generate a warning about this for good reason. So it's better to use this filter input method on PHP to get the data. So filter input will look for the bit of data, like the key value pair that you want, and then it will analyze it to make sure it doesn't have anything nasty in it and it's completely sort of safe to be processed as a standard string. And you've got different ways of filtering the input. You've got you've got sans-size string, sans-size URL, sans-size number in. You can basically, these will run different kinds of checks on the data to make sure that they conform to what you're expecting. There's some documentation on the filters there. So this is the safe way to do it, and this is the way you should do it unless you're getting some error that you can't fix in some other ways. So here we have the PHP variable name string, and we've got the filter input method, and we want to extract the name key from the get PHP variable, and this is the kind of filtering we want to apply. In this case, filter sans-size URL. And if this returns if this returns an empty string, it just says hello stranger. If this returns a non-empty string, then it takes that value and just says hello. Okay, so we're I think I've got an example. Before I go to the example, so what we're doing is we're sending this with the string here, name equals David. It's pulling out name from that, on the server side, it's pulling out name from the query string, and it's saying hello and using that name that's pulled from the query string. So let's give you a little demo of that. So here we've got our PHP, right? So here we have the query string at the end, name equals Tony. It says hello Tony. If we have name equals Fred, then it says hello Fred, and so on and so forth. So it's pulling out this value here and echoing it back to the user when it exists. If it doesn't exist, if there is no query string, then it just says hello stranger. Now on the client side, I haven't got any kind of form or anything, so it's just got a default, I think, the name set to David. So when I do load, it says hello David. In this case, the JavaScript's just sending the GET request with a query string appended to it. So in this example, PHP is just returning like, hello David or hello stranger, whatever. It could return HTML, obviously. It could return a complete page with the appropriate data like inserted into it or customized in some way. It could return XML. It could return a whole bunch of XML. But modern web services, as I said, are using JSON to pass complex data structures to the client. If you're writing something from scratch, you're going to use JSON. It's much more compact and it's much more compatible with JavaScript, which is good. So in this case, I'm going to give you a little example about how the server could return product data in JSON format. And then in this case, this is hard-coded product data. But next week, I'll show you how you could actually get that product data from a MongoDB database. And in this case, so the server's returning some product data in JSON format, and then the client is inserting this product data into the page using JavaScript. So I'll go through this little example here. So this is the server side. So all the server's doing is echoing some JSON, okay? So a bunch of JSON describing a few products, whatever, a couple of products, all hard-coded. As I said, next week we'll talk about how you can pull this data from the MongoDB database. And then if we look at the output of that in the browser, we've just got a bunch of JSON, which is what we'd expect, because that's what the server's echoing. Now, I know you can't read this. There's example code on the website, on the course website, but let's go into this in a little more detail. So here we have the Ajax part. Right, we have, when the window loads, it calls this load products function, which sets up a request, opens, contacts the products page, sends it off. When the response comes back from the server, it calls this display products method using the response that's come back from the server. And the response in this case is going to be this stuff, right? This stuff here. So we're calling load products with this bunch of JSON that's come back from the server. And the display load products is basically, because it's JSON, that's the beauty of using JSON here, we can just call json.parse on the string sent back from the server, and that will convert that into this nice JavaScript array in this case. And then we can work through this array and dynamically insert the data, sort of we're putting like some HTML tags around it and dynamically inserting it into the page. So we're getting back a JSON string from the server, and then wrapping it up in HTML using JavaScript, and then putting it inside the page by manipulating the document object model. And then, yeah, that's where we're inserting our HTML string into the page, and then we get this, the data there. So I'll show that to you now. Okay. Next one. So here's the, if we go to the products PHP, you can see it's echoing this array of products, in this case hard-coded. And then if we go to the, this is our products HTML, and what this is doing is the JavaScript sending a request to the server. It's getting back that string there. It's converting that string into a JavaScript object, and then outputting that, the data in that object into the page dynamically, by just wrapping it in HTML and inserting it into the page. So that's GET. We're accessing a web service in this case using GET. We can also do POST request where we're sending data to the server. In this case, we need to set the content type in the header, and then we add the parameters to the send method. So I'll just show you how that works. Little POST example. So on the client side in the JavaScript, we have to, when we open the request, we have to specify POST method, and this again is the file, the script we want to contact on the server. Now we need to set the request header, which tells us how we encoded it. So I haven't looked into this in a lot of detail, but we could probably write bytes or whatever into the post. But in this case, we're just sending form URL encoded. So there's a specific way in which that data is encoded. Then we do send. And in this case, the send, instead of having with a get, we append the query string here. But with post, we need to do here. We need to put our data here, and we put it in the message body. Again, set of key value pairs, name equals David, and ampersand, address equals 3 example street. And that's all going to be put inside the message body. And then on the server side, we want to pull out the name and the address. So we have the name string, address string. We're pulling out these two values using filter input. Again, we check that they're valid. If they're valid, we echo the name and the address back to the server, to the user. Otherwise, we just say hello stranger. So this is checking, when we click on send, this is checking that it's actually going to, the data's getting there and it should be outputting to the user. All right, so let's have a little look. Can we give you more example? Oh yeah, here we go, yeah. So when we click on load, it's going to send those two hard-coded values to the server, and then returning, it's going to send them back to the JavaScript, which is then going to insert what comes back from the server into the page. So it's inserting, hello David, your address is 3 example street. So they're sending this data to the server sending it back, and it's being inserted into the page here. And on the server side, this is the script, but I can't do anything with this script, because if I pen stuff here, it shouldn't make any difference. Name equals David, equals, 12, whatever. Still does the same thing, because firstly, because it's pulling it out of post, and secondly, because it's and so this is not in the message body, it's in the URL. So you can't send stuff using post by putting it at the end of the URL. It has to be in the message body, and so it only works with the JavaScript. So to make this even clearer, I'm going to give you a little registration example. So here we have a form with a name, address, and a password field, and a submit button. So this is the HTML for that. We've got name, address, standard input types, given them IDs, and then we've got the server response. What's coming back from the server is going to be injected into here. And then we got our register function. Usual stuff, creating request. We're going to post the data in this case to registration PHP. So when this register function is called, I think it's called in response to the submit button from what I remember. On-click register, right? That calls this function here. So it sets up the request, opens the connection, sets the content type, and then it's the stuff we covered a lot in the previous term, right? We're using document get element by ID to pull out the name and the address, the password that the user's typed in. That's what these 3 values are here. And then when we send the request, we're putting these things inside the message, the body of the HTTP message, post message, right? So we're setting name equals username, address equals user address, password equals user password. And when we get a response back from the server, we're just going to stick it inside the bit at the bottom as I expect. We're just injecting it into the page so we can see what it's doing, inserting it in the page. And then on the server side, we're sending these things, name, address, and password that the user's typed in. We're getting these out using filter input, checking that they exist. You know, if we were doing proper registration, we'd store that data in the database or whatever, and echo. All we're doing here is saying thank you for registering and echoing the name back to the user. And if there's some kind of error, then we can say registration data missing. So give you a little bit of demo of that. As I said, all this example code's on the course website if you want to have a look through it and play around with it. So here's my registration example. So name, David, address, 32 Acacia Avenue, password, whatever. So click submit. It's going to pull out this data from this form, post it to the server, and the server's going to echo back like a, thank you for registering type message. And that's what we're seeing here. And all of this is being done without reloading the page. Right, so that's Ajax. It's a very basic example, but it shows you how you can dynamically communicate, and then you can scale up your examples from there. So if you wanted to do like a sort of login page or something, you could do it. I'm going to give you an example of that when I talk about session management and stuff like that, so don't worry too much about that. But you can see how you can use Ajax to pull product data and insert it into the page or do all kinds of manipulations. I think it's given you enough to get started. So before last section of this lecture, I just want to say a couple of things about some of the other technologies you can use for dynamic communication between the client and server that also doesn't require reloading a page. So the limitation of Ajax is great, but it only works within a single domain. So if I'm running my JavaScript on example.com, I can't use that same JavaScript to pull data from other like Google or Twitter or whatever. You can't retrieve data from a domain that's different from the domain that the page was served from. So a script at mywebsite.com cannot communicate with a server at example.com. You get this kind of cross-origin scripting error of some kind. So it's kind of there to protect you, but at the same time, probably don't really need that kind of protection anymore. And as I say, WebSockets kind of circumvents that anyway. So this is the idea. So firstly, I've got a browser, sends a HTTP request, gets back some HTML. This HTML includes some JavaScript, let's say. Now that JavaScript can communicate with the same domain and get back some data. That's absolutely fine. What it can't do is it can't request some data from a different domain, such as bad domain. Somewhat suggestive name there, right? But this could also be a good domain. You might want to do some kind of web mashup thing where I'm pulling data from the weather data from another domain, but you can't do that using Ajax. Not possible. So there's a couple of ways around this. One way is JSON-P, which is kind of a sort of little bit of a hacky way, but it works. So this lets you use JavaScript to receive data from Google, Twitter, and so on and so forth. And the sort of the trick or the hack here is that it's perfectly fine to include JavaScript scripts from another domain. That works. So what you do is you include a script that has the data inside the script. And then the other domain can execute that script. And I suspect you could kind of execute that script yourself, but let's stick to the kosher kind of JSON-P example, and I'll explain that. So here's the hack. We're on domain 1, and we want to get some data from domain 2. So what we do is on domain 2, we write some JavaScript that calls a specific function, and we save it on the other domain in this, let's call it JSON-P demo.js. So this is on domain 2, which if we just used Ajax, we couldn't talk to. We couldn't talk to domain 1 can't talk to domain 2 using Ajax, but I can include a script from domain 2 in my website. So in domain 2, I have this script, JSONP-demo.js. This has some data. This is the data I want to include in my page, and it has a function. Demo callback is the name of the function, and it calls this function with this argument, and the argument for this function is this piece of data here. Now, this is on domain 1. We write a definition of this function. So domain demo callback, the name of this function has to be matched on domain 1. So this is the implementation of the function. All domain 2 does is it calls the function, which is defined on domain 1. So domain 2 is going to call this function with the data that's coming from domain 2. And in this case, I can work through the data because I know what the data is going to look like, and I can just output that on my page on domain 1. So on domain 1, I include this script that's running on domain 2, and that enables domain 2 is going to call this function. The script on domain 2 is going to call this function and pass this data to my page, which I can then do what I want. And as long as I know the format of that data, I can then manipulate it and insert it into the page and so on and so forth. So if you run JSONP demo HTML, then you can see the data that could potentially come from the domain being displayed on this domain. So this is fine for a single piece of data that's loaded once when the page loads. If you need to refresh data, like if you're following a Twitter feed or something like that, then you might have to dynamically insert this script tag into the document object model, repeatedly, every second or whatever. And you might have to bung some random stuff after the file name to avoid caching, because the browser would typically, if you request a JavaScript file once from a domain, the browser will cache it so that the next time you request it, it will return the file from cache, not return the file from the domain itself. To avoid that, you need to make the browser think that it's a different file that you're requesting, even though it's actually the same. So here, suppose we were dynamically inserting this script tag into the document object model. The first time we might just use JSONP demo.js. The second time we might do JSONP demo.js and then put some random rubbish after it. As long as the domain 2 understood that the random rubbish was just rubbish, then it would return the same file, but the browser wouldn't cache it. That's the important thing here. So that's JSONP, which I can't say I'm a huge fan of. It's a little bit hacky. I think WebSockets are much nicer and more modern communication method. And the beautiful thing about WebSockets is they let you have bidirectional communication. So with Ajax, your JavaScript sends the HTTP request, gets a response. Now suppose the server has a new bit of data. That server can't tell you about that bit of data until the JavaScript makes another request. So with Ajax, you've got to constantly make HTTP requests in order to get the latest data from the server, which is kind of rubbish. So WebSockets are much better. They enable bidirectional communication between client and server. You can talk to different domains. There's no problem about cross-origin communication. They've got some more advanced sort of security protocols for that. And with WebSockets, it's a WS connection rather than an HTTP connection. So it's a different protocol from HTTP. It's kind of linked to HTTP, but it's a slightly different protocol. So if you want to access a WebSocket page, you have ws:// and then whatever the URL is. Client-side JavaScript for WebSockets is dead easy. It's probably dead easy on Node, but I haven't tried it. Server's more tricky. Certainly with Java, you've got to mess about, if you're doing it in NetBeans, you've got to create all these endpoints for communication. It's all a bit of a mess. I suspect Node's a bit easier. So here's just a little example of the JavaScript, and you see how easy it is. We just create a new connection. We say, connection equals new WebSocket. This is, object-oriented JavaScript, right? And we're specifying the URL here. And then we have a bunch of events, like when the connection's been opened, we can have an event handler for that. When there's an error, we can have an event handler for that. When we receive a message, there's an event handler for that. Nice, beautiful, simple, easy JavaScript on the client side. As I said, server side, I'd have to look into how to do it on Node, but certainly with Java, it's a bit painful. I've got a lecture on that in one of my other courses I can point you to if you're interested. And I'll actually put a link to that on this module's course website. So that's been my little introduction to Ajax, JSONP, and WebSockets. And as I said, you're going to find these things pretty handy in your e-commerce website because there's 10 marks for them, and you're certainly going to find them essential when it comes to coursework 3. So this book has some nice stuff on Ajax and JSONP, and I recommend you work through the examples because obviously this lecture can only explain so much. So this lecture, been explaining, kind of covered that, right? How we can communicate with the server without reloading the page. Next lecture is going to go into how we can use PHP to interact with MongoDB, which is obviously going to be essential for your e-commerce websites.